Natural resources. In this lesson, we'll look at the science and engineering practices of constructing explanations and designing solutions, and engaging in argument from evidence. We'll also look at the cross-cutting concepts of patterns, cause and effect, scale, proportion and quantity, and stability and change. So what are natural resources? Natural resources are materials found on Earth that can be used for economic or social benefits. Humans use natural resources for many purposes, from creating materials like cloth or bricks to make clothes and houses, to generating electricity or energy, such as the use of petrol for fossil fuels. Some resources are non-renewable, meaning that once we use them up, there will not be any more. Others are renewable, meaning more can be grown or generated. Oftentimes, non-renewable resources are being used up at a rate quicker than what they replenish themselves in. Renewable resources replenish themselves at the same rate or faster than we are using them. Examples of natural resources include fertile soils, natural gas, oil, minerals, fresh water, and coal. Sustainable natural resource use. Metal, glass, ceramics, and most plastics are produced from non-renewable raw materials. For example, plastics are made from crude oil, which is a fossil fuel. Much of the energy used in the processes to form these products also comes from non-renewable resources. Raw materials can be conserved by reducing the amount of resources we use, reusing resources wherever possible, or by recycling. Humans can also make synthetic versions of some resources to help reduce the amount of natural resources used. Recycling. Recycling is a good way to reduce the amount of resources we use. Recycling turns waste into usable material again. For example, glass bottles can be recycled. The glass is sorted by color, then crushed into small pieces. Any bits of other materials are removed from the glass as it is melted. We then can use that material to make new glass bottles. What are other resources that can be recycled? Paper, some plastic, aluminum, batteries. Recycling aluminum uses less energy than extracting the raw material from ore. So why do you think that is? Recycling also prevents potentially useful materials from ending up in landfills. Recycling can help the environment by limiting the amount of space needed for landfills, as well as reducing the amount of raw material that needs to be gathered from the environment. Aluminum extraction happens at about 1,650 degrees Fahrenheit. This requires a lot of energy, and this comes from burning fossil fuels. Scrap aluminum can be melted down at around 1,220 degrees Fahrenheit. This means less energy is needed, and therefore we can save some raw materials as well as reducing the amount of carbon dioxide released. Reduce and reuse. The most sustainable change that we can make is to reduce our use of materials. Some products are wrapped in much more packaging than is necessary. If the packaging cannot be reduced, the next best thing is to reuse it. Some packaging materials can be used several times. For example, you could reuse plastic bottles by reusing and refilling them. You could reduce your water use by remembering to turn off the faucet while brushing your teeth. Or you could reduce your energy use by putting on a sweater instead of turning up the heat. So what are some other things that can be reused? Reducing and reusing should come before recycling. An item should only be recycled after it has been reused as much as possible. Even larger items like furniture can be reused. Selling second-hand items to a new home or repurposing them are both ways of reusing something. Water. Water is an important natural resource. Without access to fresh water, it is difficult for any form of agriculture or livestock farming to take place. Water stress. Water stress happens when there is not enough water available to meet demand. This can be related to water quality as well as quantity. Drinking water is usually subject to strict hygiene processes before it's safe to drink. Areas with higher water stress have a water deficit, whereas areas with low water stress may have a water surplus. Can you think of some reasons why an area might have a water deficit? What could be done to combat this? Factors such as population, demand, or climate, especially the amount of rainfall, may be leading to areas that have water deficit. Conservation can be a method to combat this overusage. Where does fresh water come from? Over 70% of the Earth's surface is covered in water. However, only about 2.5% of this is fresh. As the planet's population grows, demand for water increases. So where is fresh water found? It's found in lakes, rivers, glaciers. Water can also be found underground. Groundwater is fresh water not found on Earth's surface. It can include underwater streams and permafrost. Permafrost is ice contained in frozen ground. Aquifers are large underground reservoirs of fresh water. Solutions to water scarcity. So what can be done to ensure everyone has access to clean, fresh water? One solution is water transfer. This involves piping water from areas of water surplus to areas of water deficit. However, this method is expensive and slow to be realized. A cheaper method is to reduce water consumption. When California experienced a severe drought from 2011 to 2017, residents were asked to reduce their usage by 25% in order to save water. Desalination. Desalination plants can remove the salt from seawater. Various different processes are used to do this, but the most popular uses a method called reverse osmosis. In reverse osmosis, water is forced through a semi-permeable filter, which allows water molecules through but not salts. Pressure is added, the salt water is forced through the membrane, and fresh water is forced out. The salts are trapped behind the membrane. Desalination is expensive and less efficient than other methods. However, if improved, it would greatly reduce global water stress. Fertile soils. Historically, human settlement has been concentrated around areas of fertile soil. This is because fertile land is important for growing crops. What kind of place might have particularly fertile soils? Key factors are access to nearby fresh water sources, stable ground, nutrients in the soil. Land near rivers often has fertile soil. This photo shows the Nile River Delta in Egypt. What do you notice about the distribution of green vegetation? That green vegetation follows the Nile River out to its delta. This is an area where a lot of highly fertile soil is deposited. Before 1970, the River Nile flooded each year. The flood water helped to irrigate nearby agricultural fields. Irrigation channels were dug to help the water flow to where it was needed. The river water deposited black silt onto the fields when it receded. The silt contained many nutrients and was very fertile. In 1970, the Aswan Dam was completed. The dam helps to control the Nile's flooding patterns so that soil fertility can be maintained. However, it was expensive to build, and there is still controversy over its environmental impact. Decreasing minerals in the soil. When crops are harvested, they are removed from the field in which they were grown. This prevents the minerals that were taken up by the plants being returned to the soil when the plant dies. The amount of minerals in the soil decreases with each harvest. As a result, the land can become exhausted of its minerals. This can lead to poor plant growth and low crop yields. Replacing lost minerals. One method to overcome decreasing mineral loss in soil is the use of fertilizers. Fertilizers replace essential minerals lost through previously harvested crops. This allows crops to be grown on the same land over several years. Commonly used fertilizers made by humans are synthetic fertilizers. These contain compounds of nitrogen, phosphorus, potassium. They are referred to as NPK fertilizers as they contain all three elements. Salts and NPK fertilizers. NPK fertilizers are formulations or mixtures of different salts that contain nitrogen, phosphorus, and potassium. A salt is a compound made from the neutralization reaction of an acid and a base. The table below shows some of the salts used in NPK fertilizers and the essential elements they contain. When these salts dissolve in soil, the essential elements for plants are released. A range of NPK fertilizers can be made that are matched to the needs of particular crops. Soluble and insoluble salts. As plants absorb nutrients through their roots, the resulting salt must be soluble in water. This ensures that the plant can absorb the mineral from moisture in the soil. Some salts, such as potassium chloride and potassium sulfate, are soluble. This means they can be used directly in fertilizers. Phosphate rock, on the other hand, is insoluble. This means it cannot be used directly in fertilizers. Using byproducts. The demand for fertilizers is often met using multiple processes and different raw materials. For example, ammonium sulfate can be made in industry using a similar procedure to that in the laboratory. Alternatively, byproducts or waste products from other processes can be used as starting materials. The use of waste products or byproducts from other processes makes a process more sustainable. Ammonia produced by the Haber process and sulfuric acid produced by the contact process are often used for the production of ammonium sulfate. Another example is the production of calcium phosphate. This is produced by treating phosphate rock with phosphoric acid. The phosphoric acid is a waste product produced during the reaction of phosphate rock and nitric acid. Industrial versus laboratory production. Look at the table below comparing the industrial and laboratory synthesis of ammonium sulfate. Our reactants in the industry versus the laboratory, our waste products, the process type, the yield, the speed, the cost, and the labor. Which process is more sustainable? Synthetic fertilizers and eutrophication. Although there is a huge demand for synthetic fertilizers, they have some disadvantages. Heavy rainfall running off the surface of soil can carry fertilizers into rivers and lakes, accelerating the growth of native plants. This causes excessive algae growth at the water's surface, leading to the death of marine organisms. This process is known as eutrophication. The overabundance of fertilizers is allowing for a bloom of algae or other native plants. That growth can lead to large mats. As wintertime comes and these mats die, or as they get thick enough that the overlying material blocks out the sun from the underlying material, some of this algae or plant matter dies and sinks to the bottom. It is then decomposed by decomposers. Sometimes all of the oxygen within the water is used up by these decomposing organisms. This can lead to large amounts of fish death or other organisms found in the water that are reliant on the oxygen. Natural fertilizers. Some farms use other, more sustainable materials to promote crop growth, such as natural fertilizers. These are produced by the breakdown of plant and animal waste. One example is manure. Recycling manure for use as a fertilizer is more sustainable and decreases the amount of waste produced by a farm. However, natural fertilizers are not produced on a large scale, and they are difficult to transport and sort. Natural fertilizers are cheaper than artificial fertilizers. However, they require more manual labor to produce and store. Organic farming. Some farms go one step further, using natural fertilizers in conjunction with other natural methods. This is known as organic farming. Crop rotation is a way of maintaining soil fertility by growing different crops in fields each year. Every 3 to 4 years, a field is left fallow or empty to allow the soil to recover. Organic farming does not release harmful fertilizers or pesticides into the environment, and it can lead to increased biodiversity. However, crop yield is usually lower due to the less effective natural methods used. Minerals and fossil fuels. Minerals and fossil fuels found in the Earth's crust can be mined, extracted, and used in many ways. So what are each of these minerals and fossil fuels used for? Gold, iron, aluminum, natural gas, uranium, copper, crude oil, coal. Some unreactive minerals, like gold, are found in the Earth's crust as pure substances. However, most are found combined with other elements as compounds in ores. They must be extracted from their ores before being used. The extraction of minerals is the 5th largest industry in the world, but mining for ores is expensive and can cause damage to the environment. Uses of fossil fuels. Fossil fuels are very important and have many uses. Can you name some of the ways that we use fossil fuels? We use them to generate heat and electricity to power our businesses and homes. They're used as fuels for cars and airplanes. And they are used to make plastics, medicines, packaging, fabrics, and televisions. We use fossil fuels for just about everything. Mining for ores. As mining for ores is expensive, it is only carried out where minerals are abundant enough for this to be profitable. In industry, an ore must contain enough metal to make mining and extraction economical. The value of ores changes over time due to society and technology. For example, rocks containing only 5% copper would have been considered unprofitable in the 19th century. But today, most copper comes from ores containing 0.4 to 1% copper. Obtaining raw materials. Obtaining raw materials from the earth by quarrying and mining has negative environmental impacts. For example, explosives are used to extract limestone from rock in a process called blasting. The noise scares wildlife. Blasting also leaves large craters in the rock face, which ruins the landscape. Much of the limestone is then transported to cement factories near the quarries, and the craters can be filled with rubbish and used as landfill sites. What is crude oil? Crude oil is a fossil fuel found in the Earth's crust and is one of the most important substances in the world. It is a complex mixture of hundreds of compounds and is often referred to as petroleum. The compounds in a mixture are not chemically combined together, meaning they can be separated by methods such as fractional distillation. Crude oil is used to make fuels for transport, heating, and generating electricity. It is also used to make plastics and hundreds of petrochemicals. The early stages of oil and gas formation. Crude oil is has biological origins. Millions of years ago, plankton, algae, and other very similar animals died and collected in the sediment on the seafloor. As more layers of sediment formed around them, the remains of these animals were compacted. The bottom layers were subject to high pressure and became sedimentary rocks. Over millions of years, the combination of high heat and high pressure turned sedimentary rock into crude oil. So where is crude oil at? Crude oil is often found trapped in sedimentary rocks under the seabed. Oil rigs, or drilling platforms, are used to drill through the seabed to obtain the oil. Once the oil is released from the seabed, it is pumped in long pipelines to an oil tanker, terminal, or an oil refinery on land. There it is refined into various petroleum products. Problems with crude oil. People across the world rely on crude oil for many things, but there are problems associated with its production, scale, transportation, and consumption. Politics. Much of the crude oil used across the world is extracted in countries that are politically unstable. The high value of oil and its economic importance means that it can be a source of conflict between countries. Conflicts involving oil-producing countries can result in oil supplies around the world being disrupted. Oil supplies could also be deliberately withheld for political gain. Environment. Removing oil from the ground and transporting it can be very damaging to the environment, particularly if oil is spilled. Oil spills can be devastating to wildlife. If a bird gets covered in oil, its feathers lose their waterproof properties, meaning the bird gets cold and wet and may die. If the bird tries to clean its feathers, it will ingest the oil and be poisoned. The detergents used to disperse and clean up oil spills can themselves be very damaging to sea creatures as well. Finite resource. Crude oil is a finite resource. This means that it will not last forever. It takes millions of years for crude oil to form, but the readily extractable resources are being used up so fast that some people estimate that reserves will run out within 30 years. 90% of the crude oil extracted currently is burned as fossil fuel. In the future, alternative fuels will have to be found. Other important petrochemicals are made from oil, including some used to make medicines. Finding alternative ways to obtain these chemicals may be a difficult task, and decisions will have to be made about whether it is more important to use the remaining oil reserves for fuel or for pharmaceuticals. The Deepwater Horizon. The Deepwater Horizon oil spill in 2010 was the largest marine oil spill in the history of the U.S. crude oil industry. On April 20th, 2010, Deepwater Horizon, which was an offshore oil platform near the Louisiana coast in the United States, exploded, killing 11 workers and causing millions of gallons of oil to spill into the Gulf of Mexico. After several failed attempts to seal the leak, the oil well was finally capped 87 days after the explosion. By this time, an estimated 4.9 million barrels of oil had leaked into the ocean. The owners of the Deepwater Horizon, BP, were heavily criticized for their part in the disaster. In November 2010, the total cost of BP, or to BP, of the oil spill was estimated to be $40 billion. By August 2010, 4,678 animals had been found dead as a result of the oil spill, and many more received treatment. At least 4,000 of the dead animals were birds, 500 were turtles, and 70 were dolphins. The Gulf of Mexico's largest fishing and tourist industries were also badly affected by the disaster. The oil spill also had long-term economic and environmental impacts worldwide. Oil shale. Oil shale is a sedimentary rock. It contains shale oil, which can be extracted as an alternative to crude oil. Mining oil shale is expensive and uses more energy than drilling for crude oil. It also has environmental impacts. It can pollute water supplies around the mine through the release of waste minerals such as mercury. Newly exposed minerals can oxidize, that is, react with oxygen in the air. This can lead to acidic rainwater runoff. And shale mining also uses lots of water, between 1 and 5 barrels per barrel of shale oil produced. Tar sands. Tar sands are a mix of sand, clay, and bitumen, also known as asphalt. Open pit or strip mining is used to mine the sands, which are processed to extract the bitumen. The largest deposits are in Canada and South America. Extracting oil from tar sands is difficult. The bitumen must be extracted from the sand and other materials and then refined to produce oil. Bitumen is highly viscous, meaning that it's thick. So it must be mixed with other more liquid hydrocarbons such as naphtha before it can be piped to other locations. Sustainable use of tar sands. Tar sands are more abundant and easily accessible than crude oil and coal, but extracting them involves stripping the top layer from hundreds of square miles of land. In Alberta, Canada, former wetlands have been destroyed by tar sand companies. One way some have tried to be more sustainable is by reclaiming the land afterwards. Reclamation. It involves synthetically engineering wetlands to try to recreate the way the land was before. However, it is a long process and it can be difficult to persuade oil companies to invest in reclamation. Natural gas. Natural gas is a gaseous hydrocarbon mostly composed of methane, which is a greenhouse gas. It is found deep underground in naturally occurring reservoirs. Extracting gas often requires drilling into or through solid rock, which is difficult and costly. However, natural gas is a much cleaner fuel than coal and oil, producing between 25 and 45% less carbon dioxide when burned. The advantages of a cleaner fossil fuel must be weighed up against the difficulties involved in extracting it. This is known as cost-benefit analysis. Gas safety and transportation. Gas has a low density and is compressed before it can be transported. Occasionally, gas leaks can occur during this process, adding to the Earth's greenhouse effect. Natural gas is also combustible and must be handled carefully. When gas is used in homes, strict regulations ensure that it is safe. Drones or airplanes are used by some companies to monitor above-ground gas pipelines and make sure no activities take place that could result in a leak. Automated machines, known as pigs, are sent down the inside of pipes to check and clean them. The term pigs originally came from the squealing noise that these machines made when they were sent down the narrow pipes to clean. However, they have since become known as pipeline inspection gauges. Coal mining. Coal mining refers to the extraction of the fossil fuel coal from the ground. Various methods are used to achieve this. Open pit mining involves digging a large, deep pit. Coal is mined from within the pit. Strip mining involves digging a long strip of land in order to access a coal seam underneath. Underground mining involves digging a deep main shaft with tunnels extending outwards. What potential issues with these methods can you think of? Environmental impacts such as scars in the landscape, danger to workers, especially in underground mining, issues with water contamination similar to oil shale mining. All of these and more may be issues with these forms of mining. Minimizing the impacts of coal mining. Coal mining can be dangerous and leave large scars on the landscape of an area. So how can we minimize these problems? Coal miners who work underground do a difficult and dangerous job. An average of 26 miners died per year between 2005 and 2014. One way to prevent this is to use remote-controlled machines to mine coal. There are also initiatives to ensure that abandoned coal mines are cleaned up and that the landscape is returned to as close to its original state as possible once complete. So let's summarize. Are these statements about natural resources true or false?